This is there was an elementary school here in Richmond. It's called William Fox Elementary. It's in a historic area. We were able to get our hands on the original construction documents. Ironically enough, these documents, the way we got our hands on them was Rick used to work at the design firm that had them. So it was, we got real lucky and we got our hands on these, had a kind of a relationship, not the relationship that we normally talk about, but a relationship with an engineering firm. And so we were able to get our hands on these. The building was originally built in 1911. Again, it's a historic building. It's in a historic area of Richmond City. In February, they had a 3-alarm fire on this particular building, caused extensive damage, particularly to the roof structure. And it was a really high visibility loss. They very high community importance. They had vigils for the school itself. Fortunately, this fire occurred overnight, so nobody was hurt. But they literally had vigils for the school, candlelight vigils for a building. So I pulled these images from pictometry just to give you some perspective on just how much damage there was. This is the building about 6 months before the fire, and this is the building after the fire. You can see pretty much the entire roof has been consumed, pretty extensive damage to obviously to the roof, but also to that second level floor structure. So our scope was really to figure out where we needed shoring and stabilization. The city had really locked down the building and wouldn't even let fire investigators do their work unless a structural engineer signed off on it. Then do an evaluation for, can we repair this building from a code perspective? And then the last part was an economic analysis. So I'll walk through a couple of pictures here. This first slide, obviously this is pretty severe damage. This is floor framing. That stuff on the photo on the right that kind of looks like spaghetti, those are actually metal chairs. So they just basically fell right through the floor. Obviously, if the floor can't hold metal chairs, there's no way I'm walking up there, and I'm not recommending a fire investigator or a contractor go up there either. So identifying locations like this where it's unsafe, but then also looking at other conditions that may be unsafe. So look at where things may have been destabilized. The entire perimeter of this building had a very long eave. It stuck out about 3.5 feet. And you can see there, again, this is from on the right-hand side, this is from the original construction drawings. That piece was actually a 4x10, so it's a pretty solid piece of wood sticking out 3.5 feet. And the way it stabilized, or was stabilized, was that back end was connected to the roof rafters. Well, when the roof rafters go away, it's now a seesaw floating on top of a giant masonry wall 35 feet in the air. So we wanted to make sure we're identifying, we need to get those off before we start letting people in and around the building, because a wind gust in the wrong direction could send that thing tipping over. So the other thing that we wanted to look at was what parts of the structure may have been destabilized as a result of this fire. So this, what you're seeing in the middle here, this image was taken with a drone. This was an auditorium area. Previously, the roof and ceiling framing braced the top of this wall, so all the loads could get, transferred into the correct places. Well, when that roof and ceiling came caving in, there's now no brace at the top. So recommendations for how do we stabilize it? Where can we put shoring? We wanted to identify locations that if the wind blew at just the right angle or just the right wind gust or anything like that, we weren't going to have people inside the building and then a 15-foot tall brick masonry wall fall down right next to them or on them. One of the big challenges on this one was access difficulty. Portions of the structure were really difficult to access because all the debris just fell straight down. And like I said, the city had really locked down this building. They wouldn't let anybody inside. So how could we collect this information? We used technology. So we used a drone to capture the condition of the structure from the outside. And then we used Matterport to capture the condition of the structure from the inside. So we have a full model, full 3-dimensional model of the building, both from the outside and from the inside, that we could reference in the event that we weren't able to get back in. So again, that we're doing the drone pictures. These can be really, really powerful. Something like this can be really nice to show, hey, we need to remove the eave framing around these locations. Something like this really captures just how much damage there is. Parts of the structure, obviously, these chimneys would have been very, very difficult to get to, right in the middle of the building, tons of fire damage around it. there was some concern initially, and we can get the drone right up next to them to see if there's cracks or movement or anything like that. So the next part, we wanted to capture everything we could on the inside. For those of you that haven't seen Matterport, this is a full 3D model of the inside of the building. It'll show, I've just kind of put a couple of screenshots in there, but really what we can do is almost virtually walk through this building like you would in Google Maps. So we can see every piece of it. It makes it really, really helpful, particularly when they lock down a building or access to a building. If you get out there and you say, oh shoot, I can't remember, did the floor framing change direction in this location or not? It's super easy. You can just walk right through the building, see where the floor framing is, see, whatever kind of trim components there are, how much damage there is. It makes it, you can capture the full condition of the inside of the building. So the other part of this is one person couldn't do all this work. We needed to leverage all the people in the organization. And this is where we kind of fall back to what Rick was talking about and Amy was talking about, building out that team within the region and really having this, having a good network to draw from. So we needed structural engineering for both the site investigation and the drone flight, potential for design of shoring systems and any repairs. We didn't get the C&O work for the fire investigation. They engaged somebody before we ever got involved in this claim. But we needed the fire investigator, Joe Boisseau, handled this from right here. He handled the Matterport scanning. We needed building consulting work because we needed to figure out, is it more economically viable to tear this building down because of the age and rebuild it from the ground up, or can we repair it in place? So we needed an order of magnitude pricing as well as a valuation of the building. We didn't have somebody real locally that had the specific experience, but we were able, because we were able to collect so much information using our technology, we were able to leverage one of our guys down in Texas. Wade helped out with this one and put together the estimates. And so we were able to present this. We answered all of their questions by using just what we had in-house, just the team that we have around us.